Hi everyone, welcome back. Today we are going to see about the zones of production. So, zones of production. A power system contains generator, transformer, bus bars, transmission line and distribution line, etc. So here there is a separate production schemes for each piece of equipment in a power system, such as for generator it needs generator production, for transformer it needs transformer production, for bus bar it needs bus bar production, etc. Thus power system is divided into n number of zones for the better production of the whole power system. So the productive zones are planned in such a way that entire power system is collectively covered and no part of the system is left unprotected. And this is the diagram for the zone of production. Here there is for generator, it needs some specialized generator production, and for transformer we need transformer production, and for transmission line we need transmission line production. So for all the production, if for generator we are using the circuit breaker, and for transformer we are using the 2 circuit breaker, and for transmission line we are using the 2 circuit breaker, etc. So here all the component in a power system, all the part of the power system should be safe, should be protected. None of the area should be left unprotected. So here, and all the area should be overlapped for the better quality and better protection also. So here, an adjacent productive zone must overlap each other. So failing which a fault on the boundary of the zones may not lie in any of the zones. For example, there is a fault which is located some of the boundary of the generator or boundary of the transformer. So now whether the transformer circuit breaker will operate or the generator circuit breaker will operate, because it's near to the boundary of the both transformer and generator. So here it is based on the distance. It is based on the distance where the fault is located. So immediately, as soon the generator or the transformer should isolate the faulty section without any time delay, so that the overlapping between the adjacent zone is unavoidable. It should be always overlapping. If a fault occurs in an overlapping zone in a properly protected scheme, more circuit breaker than the minimum necessary to isolate the faulty element of the system would trip. And the primary and backup protection. So the power system is divided into various zones of protection, and there is a suitable protective schemes for each zone. So here, if fault is occurred in any particular zone, it is a duty of the primary relay of the particular zone is to isolate the faulty element. Suppose the primary relay is first line of defense. It is failure. Due to any of the reason, the primary relay is failed to operate. So without any time delay, the backup relay, the backup protection schemes, it come and operate in order to clear the fault. So it is the second line of defense. So here the percentage of failure rate of various component. So the major fault which are occurred only in the relay. So the relay is nothing but which is used to sense the fault, which is used to detect the fault, and it gives the information to the circuit breaker and where the fault is located. So the most of the fault is occurred only on the relay. So we have to concentrate on the design, development, installation and maintenance of the productive relay in order to ensure the reliability. So the reliable should be always 95%. It should be always 95%. So the proper designing, installation and maintenance of relays, circuit breaker, tripping mechanism, wiring should be achieved. If the primary relays fail to operate without any time delay, immediately the backup relay should come and clear the fault. Otherwise, the entire system is maybe damaged. So, and sometimes the local backup is also used for the clearance of fault. So it may be a remote backup, a relay backup, or it may be a breaker backup. So if it is a remote backup which is located in the near neighboring station, if the primary relay is got failure, immediately the neighboring station, the remote backup will collect all the information and to trip this whole system with the help of circuit breaker and relay backup. So it is a local backup which is located on the same station. So additional relay can be used, additional CTPT can be used, so the overall cost gets increases. So it is applicable where the breaker, the remote backup is not available. And the next one, breaker backup. So here it is also a local backup which are located in the near to the bus bar. If any of the circuit breaker is not working, it is a failure. So the remaining circuit breaker which are connected with the same bus bar, so all the circuit breakers gets tripped in order to ensure the reliability and stability of the power system. And this is the assessment. So what is the purpose of backup protection? It is to increase the speed, to increase the reach, to leave no blind spot, and to go against the failure of primary. Put your answer in the comment section, and this is the few reference books for our topic. Thank you.